So 19 and 23 definitely can use a little bit of help here. So if we're supposed to find each point of discontinuity and then classify it, and my key is not incredibly descriptive here, so I'll just talk about when we have a function, what is supposed to happen. So the first thing I would notice about this function that we can't see most of is you take a very careful look at the functions themselves just for a moment. And I'm just going to notice that that first function, 3 minus x, itself, we know what that is. I hope we know it's a straight line. And it being a straight line means it itself is continuous. And that rule, 3 minus x, only works up until x equals to 2. And then the other function, x over 2 plus 1, also is a line. It's a line 1/2 x plus 1, also continuous, but we only have it from 2 onward. But I can see this function is automatically not defined at 2. So there's definitely a discontinuity at 2. The question is that continuity removable or not? And that's just a question of, does the limit actually exist? So in theory, or technically, I guess, what I'm checking is I'm checking what the limit is as x approaches that 2 from the left of f of x. And if I had more room on my key, I would write all this out. So this would mean I'm going to use the rule 3 minus x, because that's for values that are less than 2. I'll plug 2 into here. 3 minus 2 equals 1. And then I'm going to check the limit as x approaches 2 from the right of f of x. And my goal here is just to see, does this limit exist? As I approach 2 from either side, do I go toward the same y value? That's the question. So I'm going towards the same y value, but I get to that y value and it's not there, then it's just a hole in the graph. But if I approach from the left and I'm going towards 1, and I approach from the right and I'm going towards something else, that's going to be a break in the graph. So I'll take the limit as x approaches 2 from the right. That's going to give me 2 over 2, right? Plus 1. That equals 2. Oh, 1 and 2 are not equal to each other, right? So as I'm approaching 2 from the left, I don't know, this will be a straight line. And then as I get to 2, the y value will be 1. But as I come at it from the right, it'll be y value of 2. Please ignore the fact that my slopes are wrong. It's embarrassing. That's like that, and that's like that. So they're not going to the same place. That's why I'm saying f is discontinuous at x equals 2, and it's not removable. The limit didn't exist. Because it matters which side it approach 2 from. So for 23, it's a more of a graphical approach. We can see there's some kind of business happening at 0, something crazy happening at x equals 1. At 0, it's just a hole in the graph. The limit exists, so that would be considered removable. But at 1, it's a full-on break. As I approach 1 from the left side, the y value is 1. As I approach 1 from the right side, the y value is 0. Those numbers are not equal to each other. It's a break in the graph. It's non-removable.